Welcome to my channel. In this video, we are going to work on some numericals. Before we start, let us see the important formulae that we have discussed in this chapter electricity in all the previous videos. V is equal to IR. R is equal to rho L by A. R is equal to series resistance, parallel resistance, 1 by R1 plus 1 by R2 plus 1 by R3. Then expression for power, power is equal to VI, or power is equal to I square R, or power is equal to V square by R. Based on the data which is given, we will use one of those formulae. Then energy is power into time, then heat developed is I square RT. So now we will see the problems which cover all these different formulae and how to solve the numericals. The first problem. An electric iron draws a current of 3.4 amperes from 220 volts supply line. What current will it draw when connected to 110 volts supply line? So first we will see, we have to calculate the resistance. So what is the given data? Let us identify. So I is given 3.4 amperes, then V is given 220 volts, and we need to calculate R. So from Ohm's law we know V is equal to IR, so from which R is equal to V by I. So that is equal to 220 by 3.4. And when you calculate this, this comes to 64.7 ohms. Units of resistor is ohms. So this one. Now what current will it draw when connected to 110 volts supply line? That means now instead of 220 volts, now supply is changed to 110 volts, but the resistance remains the same. So now having calculated this resistance, now let us write R is 64.7 ohms, V is 110 volts. Now what current will it draw? Which means I need to calculate I. So from the same formula, V is equal to IR, I is equal to V by R. So that is equal to 110 by 64.7. So that comes out to be 1.7, and the unit of current is amperes. So the answer is 1.7. That means 1.7 amperes current is drawn by electric iron when connected to 110 volts supply line. 110 volts supply. So we have used the first formula, V is equal to IR. Now let us see another problem. A copper wire has a diameter of 0.5 mm. So let's write D is equal to 0.5 mm and resistivity of 1.6. So resistivity is, so diameter is 0.5 mm means we can write R radius is D by 2. We know that R is D by 2. So that is 0.25 mm. So when you convert it into meters, 0.25 by 1000 meters, or simply you can write 0.25 into 10 to the power of minus 3 meters. And then area of cross section, let us calculate area of cross section. A is equal to pi r square. So pi is 22 by 7, r square is 0.25 into 10 to the power of minus 3, which we have calculated, whole square. So this when you simplify, you get 1.1964 into 10 to the power of minus 6, 10 power minus 3 whole square. So, that becomes 10 power minus 6 and the units will be meter square. Now, resistivity rho is given 1.6 into 10 to the power of minus 8 ohm meter. Now, the question is, what will be the length of this wire? So, you have to calculate L. You have to calculate L to make the resistance of 10 ohms. So, R is given. R is 10 ohms. So, with this data, what will be the formula that you have to use? We know that rho is equal to RA by L. We have written. So, resistivity is RA by L, from which I can write L is equal to RA by rho. Now, we have R, we have calculated A and rho is given. So, substitute these values now to get the value of the length of the wire. Therefore, L is equal to, let us substitute, R is 10 into area is 0.1964 into 10 power minus 6 by rho is 1.6, this is the value, 1.6 into 10 to the power of minus 8. So, this goes up, so it becomes 10 square. 10 square into 10, 10 cube. So, this becomes 196.4 by 1.6, or you can write 1964 by 16 to simplify. So, that is equal to 122.7 meters. You can check that value. So, length is equal to. Now, there is another question here. How much does the resistance change if the diameter is doubled? Now, resistance is inversely proportional to area of cross section, or it is inversely proportional to square of diameter or square of radius, whatever. Therefore, if R is doubled, if the diameter is doubled, not R, if the diameter is doubled, that means D is now equal to 2D. Then R will be square of the diameter. So, 1 by 2 square or 1/4. So, the resistance will become 1/4 because it is square. So, diameter is in the denominator. So, it becomes 2 square of the diameter, therefore 2 square. So, that becomes 1/4. Then we will move on to the next problem. Draw the diagram of a circuit consisting of battery of 3 cells, 2 volts each, resistors 5 ohms, 8 ohms, 12 ohms in series, and an ammeter to measure the current through them, with a voltmeter to measure the potential difference across 12 ohms resistor. Then the question is, what would be the readings in the ammeter and voltmeter? So, first let us draw with the data which is given circuit. So, let us draw the circuit. So, I have 3 resistors in series. So, I will draw them and then I will take an ammeter here and I have how many cells? 3 cells. So, the battery consisting of 3 cells, positive, negative. So, 3 cells, each of 2. So, the total becomes 6 volts. 3 into 2, 6 volts. And then I will just give a plug key here. And the direction of the current will be from positive to negative. So the current direction, so current flows in this direction. Current flows in this direction. And now we have an voltmeter connected across the resistor. Voltmeter connected across the resistor. So resistors are 5 ohms, 8 ohms, 12 ohms. So this is the circuit. So first part of the question is draw the diagram consisting of all this. So we have finished this. Now what is that which we need to calculate? We need to calculate what is the reading in the ammeter. That means I have to calculate the current flowing through the circuit, and what is the voltmeter reading. That means what is the voltage or potential difference across this 12 ohms resistor. Now these are in series. So in series we know that the series combination R is equal to the equivalent resistance. R is equal to R1 plus R2 plus R3, etc. So now we have 3 here. So R is equal to R1 is 5 ohms, 5, this is 5, 8, 12. So 5 plus 8 plus 12, so that is 25 ohms. So R is equal to 25 ohms, and V is equal to 6 volts. How did I get 6 volts? There are 3 cells, each of which giving 2 volts, so that becomes 6 volts. So I got like this. So voltage is 6 volts. Now I have to first calculate the current flowing through the circuit. What is I? Again from Ohm's law, V is equal to IR, I is equal to V by R. So V here is 6 and R is 25. So that is equal to 0.24 amperes. Therefore, the reading in the ammeter reads 0.24 amperes. The current reading in the ammeter here will be 0.24 amperes. Now, we have an voltmeter here. So we have to calculate the voltage. So the same current will be flowing. So I is 0.24 amperes, and now R is 12 ohms. Why 12 ohms? Because we are calculating across this 12 ohms resistor. So R is 12 ohms. Now what is the voltage across this 12 ohms resistor? Because it is given voltmeter to measure the potential difference across 12 ohms resistor. So we have to calculate across 12 ohms. Again V is equal to IR. So that is equal to 0.24 into 12. So that will be equal to 2.88 volts. 2.88 volts. So the voltmeter reading here will be 2.88 volts. So voltmeter reads, therefore reads 2.88 volts. Next, another one. An electric lamp of 100 ohms, a toaster of 50 ohms, a water filter of 500 ohms are connected in parallel to a 220 volts source. What is the resistance of an electric iron connected to the same source that takes as much current as the 3 appliances? That means it takes the same current. And what is the current through it? Now, these are connected in parallel. So first let us write the formula for resistance in parallel. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now here R1 is lamp resistance, that is 100 ohms. R2 is toaster, resistance of the toaster, that is 50 ohms. R3 is water filter, that is 500 ohms. So these are given in parallel, and voltage V is 220 volts. given. So first 1 by R is equal to 1 by 100 plus 1 by 50 plus 1 by 500. That is equal to 5 plus 10 plus 1 by 500. So that is equal to 16 by 500. 1 by R. Therefore, this implies R is equal to 500 by 16. So that is equal to 31.25 ohms. Now, an electric iron is connected to the same source that takes as much current as the 3 appliances. So the 3 appliances, same source, and therefore, so what will happen? The R, the resistance of electric iron will be the same. So will also be 31.25 ohms because it is connected to the same source and draws the same current as there. Now we have to calculate what is that current. So V is equal to 220 ohms, R is equal to 31.25 ohms, I is equal to how much? So we need to calculate the, so what is the current through it? So I is equal to, so I is again V is equal to IR, therefore I is equal to V by R. So that is 220 by 31.25, that is equal to 7.04 amperes. That 0.04 amperes. Then an electric motor takes 5 amperes from a 220 volt line. Determine the power of motor and the energy consumed in 2 hours. So let us find out what is given first. I is equal to 5 amperes, V is equal to 220 volts. First determine the power of motor. So power P. What is the formula for power? Power with the given data we can use VI. So power is equal to 5 into 220. So that is equal to 1100 and the unit of power is watt. So 1100 watt. Now time is given 2 hours. So convert these 2 hours into seconds. That is 2 into 60 minutes and then 60 seconds. So that when you convert hours into seconds, 2 into 60 into 60, that is equal to 7200 seconds. Now you also need to calculate the energy consumed. So energy consumed E is equal to, we know that the formula is P into T. So P is 1100 watt we have calculated into T is with the given converted into second 7200. So that is equal to 7.92 into, let us put in terms of 10 powers. So 10 power 6 and the units are joules. So the value is 7.92 into 10 power 6 joules. Now another one. An electric bulb rated 220 volts and 100 watts. When it is operated at 110 volts, calculate the power consumed. So, what is given to us? Power P is 100 watts for the electric bulb. V is 220 volts. Let us now first calculate the resistance. Resistance is, so we know P is equal to V square by R. Therefore, R is equal to V square by P. Now, V square is 220 into 220 by P is 100. So, when you simplify that, that will be equal to 484 ohms. The resistance of the bulb remains unchanged. And is equal to 484 ohms. Therefore, now R is equal to 484 ohms and V now is 110 volts, 110 volts when it is operated at 110 volts. Now, calculate the power consumed. So, now we have to calculate power. Again, power is equal to V square by R, same formula we can use. So, V is now 110 into 110, that is V square, by R is 484. So, that comes to 25 watts. 25 watts. An electric iron of resistance 20 ohms takes a current of 5 amperes. Calculate the heat developed in 30 seconds. Now, what is given? R is given 20 ohms, I is 5 amperes, time is 30 seconds, and heat produced or developed, what is the formula? Heat H is equal to I square RT. Now, all these three are given. So, let us substitute 5 square into R is 20 into time is 30. So, H is equal to 15,000 joules. So, this is the heat developed. And the final one. Which one uses more energy? A 250 volt TV set in 1 hour or 1200 watt toaster in 10 minutes. So, we are using these two appliances. So, we have to calculate which one uses more power. Now, for TV set, power is 250 watts, time is 1 hour. Now, this 250 watts, let us convert to kilowatts. So, 250 by 1000 kilowatts. So, that is 0.25 kilowatts. Time is 1 hour. Now, uses more energy. So, you have to calculate energy. Now, what is energy? Energy is E is equal to P into T. So, here P is 0.25 kilowatts into 1 hour time. So, that is equal to 0.25 kilowatt hour. This is the energy consumed or used by TV set. Now, for toaster, power is 1200 watts and time is 10 minutes. This 1200 watts again we will convert to kilowatts. So, that will be equal to 1200 by 1000. So, that will be equal to 1.2 kilowatt. Then 10 minutes let us convert it to hours. So, 10 by 60 hours. That will be 0.167 hours when you convert that. Therefore, energy consumed or used is E is equal to P into T, once again formula, and that is 1.2 kilowatt into 0.167 hours, which will be equal to 0.20 and kilowatt hour. Now, when you look at these two values, 0.25 kilowatt hour and 0.20 kilowatt hour, obviously we can say that TV set uses more power than toaster, because 0.25 is greater than 0.2. So, keep watching, keep learning. Thank you.